Okay, and do I see you guys on Friday?
Yeah.
Oh, no, I don't think I do see you on Friday.
It's e-learning.
But it's an e-learning day 3, and I don't think I see you on day 3.
Do we see tomorrow?
You see me tomorrow? Yeah, you see me tomorrow. So, you don't need to worry about me on e-learning day.
Let's go.
That's right. Of course, if you get to missing me, you can always pull up a video and just play it in the background. All right, so here we go. We're on our notes. 5-1, no calculator. We're going to find sine and cosine if tangent is 3/4 and sine is greater than 0. Kind of got cut off. That should be greater than 0. So let's look at this given. This is actually not new. You know how to do this already. So this is the given. All right? So let's think about what we know. We know we got a triangle out there somewhere. Opposite is 3 and adjacent is 4. Now, what do I not know? Well, I don't know the hypotenuse, but I can find that, right? I don't know where to draw it. But actually, I have everything I need to figure that out. I can't help you. If I have any, they're in that bin back there that says academic on it. Otherwise, you'll have to print them off Schoology. Okay? Now, let's think about this for a second. This says the tangent is a positive number and the sine is a positive number. Which quadrant does that happen in? Quadrant 1. So using both pieces of information, you can deduce the quadrant. So that's a little different than when we did this before. Before I said it's in quadrant 4 or something. Now you know. Here it is. Opposite is 3, adjacent is 4. We can do our Pythagorean theorem and find the missing side, which this is an easy one. It is 5. And then we can answer the question. What's the sine of the angle? This is your angle. What's the sine of your angle? 3/5. And the cosine of the angle? 4/5. Problem done. That is exactly what we did before with just this little added twist in here. All right, there's another one. Cosine is 4/5. And tangent is negative. Now, does everybody understand less than 0 means negative? So this one is not going to be quadrant 1 because the tangent is negative. So which quadrant has a positive cosine but a negative tangent? Quadrant 4. Now, if you're confused by that, I want you to stop and remind yourself, cosine is affiliated with x. Cosine is x, x over r. Where is x positive? Over here, right? But we already said it can't be quadrant 1, so it has to be quadrant 4. Cosine is 4/5. Pythagorean theorem, what's this side? -3. Don't forget those negatives. Some of you forgot them on the test. That's bad news, but keep those negatives. And this time we want sine and tangent. All right, what's the sine of this angle? -3/5. And what's the tangent of that angle? -3/5. Done. Easy, easy, easy. So a little review to get us going before we hit this next part, which is easy, but it's a little bit different. All right, we want to simplify tangent times cosine. Now I want you to look on your sheet. Some of them are pink, I don't know what color, orange. Okay? And up in the corner over here on the right-hand corner, I wrote in, what? What did I say about tangent up there in the corner? Tangent equals sine over cosine. So I'm going to take this tangent and I'm going to rewrite it as sine over cosine. And then I'm going to multiply it by cosine over 1. Thank you. Is that okay with everybody? And what's going to happen? This is a multiplication problem. So what's going to happen? They're going to cancel. Your job was to simplify. This simplifies down to just sine. Okay? Look at the next one. Now, you've got this reference sheet. This stuff's brand new to you. So you're kind of looking at it carefully. You've got a couple of different ways to do this. There's lots of different ways to do it. But look at that numerator for a minute. Do you see that on your sheet anywhere? What does it say about 1 plus tangent squared? 1 plus tangent squared is secant squared. So I'm just going to replace that with secant squared. So now I have this. I think it's easiest when you have a division problem like this. I think sometimes it's easiest to think of it in terms of an actual division. So in other words, instead of writing it on top of each other, I'm writing it horizontally. Secant squared divided by cosecant squared. Now bear with me. If you're wondering why I'm doing that, just hang in there for a second. What's secant? Secant is the reciprocal of cosine. That is not on your sheet. You need to know that. You need to have memorized that secant is reciprocal of cosine. So this is 1 over cosine squared divided by, what about cosecant? What's that? Cosecant is 1 over sine. So this is going to be 1 over sine squared. So 1 over cosine squared divided by 1 over sine squared. How do I handle this? Fraction divided by fraction. Keep, change, flip. Yep. So 1 over cosine squared, change it to a times, flip it over. That's why I like to write these as a division. So then I can keep, change, flip. Nothing cancels, but when I combine them, I get sine squared over cosine squared. Would you agree with that when I just multiply? And what do I know about sine over cosine? It's tangent, isn't it? Isn't sine over cosine tangent? So this is just tangent squared. So who would have thought, look here at this, who would have thought that that mess would simplify down to tangent squared? All right, take a look at your sheet and tell me your thoughts on problem C. What are your thoughts on problem C? Do you have a thought? What? Say it out loud. Say what's the thing?
Sine and plus cos equals 1.
Okay. It doesn't say sine plus cos equals 1. What does it say? Sine
Squared.
squared plus cosine squared is 1. And that's called an identity because it's true no matter what you're taking sine and cosine of. So in other words, I don't care what you put in this parentheses, if it's the same thing, if that and that match, this is always going to be 1. Sine squared plus cosine squared is 1. Always. It's called the fundamental trigonometric identity. So in this case, what's in the parentheses is negative x, but that doesn't matter. That could be anything. That could be pi. That could be the square root of 92. It could be anything. As long as these are the same, sine squared plus cosine squared is going to be 1. Now, that identity is sine squared plus cosine squared. Regular sine plus regular cosine doesn't equal anything. It has to be squared. All right, that was easy. Any thought about this one? Today's day 1, you're just getting started. These can be a little tricky. But think about what we've done on our other problems. What do you think might be something that we could do here? Into?
Sine over cosine.
That sounds like a wonderful plan. This is sine over 1, and this is sine over cosine. That's beautiful. Now, Van, by the way, your text is pretty good, Van. Cotangent. What's cotangent? If tangent was sine over cosine, then cotangent will be cosine over sine. Now notice, I didn't put that on the sheet, because you're supposed to know that tangent and cotangent are reciprocals. And reciprocals mean turn it over, right? All right, so far so good. What do you want to do now? This is a plus. Nothing's going to cancel, kids. It's only going to cancel if that is a multiplication. It's not. If somebody said, can we distribute? And the answer is absolutely yes. So take sine times this, so we get sine squared over cosine. We're multiplying these two, so sine squared over cosine plus, okay, now wait, what happens when I multiply now? This times this, what's gonna happen? The signs are gonna cancel and leave me with just cosine? Cosine? Because I'm taking sine over 1 times cosine over sine. Any thought about what we might want to do next? Don't look on the sheet. This is arithmetic. You are adding fractions. So what do we need when we add fractions? A common denominator. So what's my common denominator going to be? Cosine. That one already has a cosine. This one needs a cosine. So I'm going to give it a cosine. And now I have sine squared plus cosine squared over cosine. There's my common denominator. So I can add my fractions together. Sine squared plus cosine squared. Wait. What's sine squared plus cosine squared? 1. So your answer is 1 over cosine, which you know is the same as what? 1 over cosine is secant. So remember, your job was to simplify. So you took this thing right here, you changed it into sines and cosines, distributed, got a common denominator, used our identity, and we're done. You gotta admit, it's kind of fun.
Yeah, for
Kind of fun.
sure.
Okay, E. Again, day one, I mean, you've never done this before until today, but does anything pop out at you when you look at that? Well, there are V's in there, but the angles don't really matter. It is important to know that, okay, I'm gonna give it away. What's in my denominator here? 1. If, however, this had been a V, that would not be 1. Because what's the key to combining these? Same angle. It was, however, an X, so the denominator is just 1. So I've got this secant squared minus tangent squared. The letter is irrelevant. It's a variable. So I don't care what you make it an A or something. I don't care. It's fine. Now, when you look at your sheet, this is a little tricky. You look on your sheet. Do you see anything that ties together secant squareds and tangent squareds? Isn't there an identity, a formula, that says 1 plus tangent squared is secant squared? There is, it's on the sheet. So, could I take that right there and replace it with 1 plus tangent squared? Would that be okay? If I took that secant squared and replaced it with 1 plus tangent squared? Well, if I do that, what happens? The answer to the question is just 1. This hideous looking thing simplified down to just 1. I want you to look up here for a second. Guys, this is an equation. All right, it's an equals. You can move things around in an equation. What would happen if I subtracted this over to this side? What would my equation say? 1 equals secant squared minus tangent squared? Secant squared minus tangent squared is 1. Because of that right there. I don't know why you guys don't look as excited as I do. All right.
Inside.
F, here we go. We're almost done. Got a couple more simplifies, and then we're going to solve some equations. All right, but first we got to simplify. So pretend you're stranded on a desert island. Your future depends on you being able to simplify this. What occurs to you? I'm open to any and all suggestions. What do you think about when you look at this? Jake? It is. Tangent is equal to sine over cosine. So, Jake, if that's the strategy you're going to take, I think I would maybe want to write this as secant squared divided by tangent squared. Now, I'm just working on Jake's thing here. And then secant squared is 1 over cosine squared divided by sine squared over cosine squared, which is a fraction divided by a fraction. So 1 over cosine squared times cosine squared over sine squared. So those cancel So does this just boil down to 1 over sine squared? Now, I haven't done anything with this yet, so he's just coming along for the ride. So I had my original 1 over sine squared. And then I did all this stuff, and I ended up with another 1 over sine squared. And these guys are added together. So what's 1 over plus 1 over the same thing? They already have a common denominator, so I'm ready to add them. What do I get? 2 over. Exactly. So 2 over sine squared. That's okay. It's fine, actually. That's fine. If you wanted to, you could write that as 2 cosecant squared. Because 1 over sine squared is cosecant squared.
Are there multiple ways to do that?
There are lots of ways to do that.
Because I was gonna try to find like a common denominator, because when you would get.
To add these, you mean? Yep.
Yeah. Okay,
Yep, absolutely you can. Yeah, there are lots of ways. Ultimately, Jake, we better end up with the same thing, but there's lots of different ways we can do it.
How would you be able to do it by replacing the secant squared with 1 plus tangent?
You can, I mean, yeah, that's true. You can absolutely do that. But then what's the next step after that? And then,
The tangent and the, like both of the tangents cancel out.
actually, you gotta be careful with that, because if you have a plus or a minus, Nyla, you cannot cancel just part of that. You have to factor first and then cancel. Now, what you could do, algebraically, if you wanted, this can be broken apart into 2 separate fractions, and then you can cancel. I wouldn't recommend that though, because look at what we have if we do that. We still have this guy, and now we're gonna have this fraction plus another fraction. Now we got 3 fractions. So while it's absolutely true, there's nothing wrong with it. Whatever you do, you have to be able to continue it. So it's, what you were suggesting is fine, but not the canceling. This does not cancel. Yeah, fun stuff. All right, one more. G. Letter G. Anybody have a thought on that? Jake.
So it says on here that like sine plus cosine would equal 1. It was sine.
Okay, wait. It's not sine plus cosine. It's sine squared plus cosine squared. Yep. Go ahead. Which is actually handy. Oh wait.
You guys know.
Oh no. Yeah.
Never mind.
I wonder if that was supposed to be a square. Well, it's not, so let's just go with what we got here. I like the way you were thinking though, Jake. Can I, since that's a sign, can I do anything with cosine squared? Now, remember, like you said, sine squared plus cosine squared is 1. If I move this over to here, what would that equation say? If I took this and subtracted it over here, it would say cosine squared equals 1 minus sine squared. So could I take this and substitute it in here?
Yeah.
At least then it'll be sines.
Yeah.
So sine x minus 1 minus sine squared minus 1. Sine x minus 1 plus sine squared minus 1.
With the cosine.
We replace cosine squared with 1 minus
Oh.
sine squared.
Gotcha.
clean that up. So I got sine squared plus sine minus 2. Don't look on your sheet. Think like an algebra student. You notice anything about that?
Like,
Can you factor it or something? You absolutely can. This is a quadratic equation. This is the same as having x squared plus x minus 2. Does that factor? Does that little quadratic factor? It would factor x plus 2, x minus 1, is that right? So how will this factor?
sine x.
Sine x plus 2
Yeah.
and sine x minus 1. Wow, your minds are blown. Your minds are blown. Hey, we're not talking about parties.
This is a party right here in this room.
Yeah, this is not a party right here.
I'm having more fun.
All right. You guys weren't around, you weren't even born yet, back when I was a fun person. Prom of '85, I used to be in charge of prom. Prom of '85 was a disaster. I mean, a total disaster.
Kids factoring wrong, what's going on?
So anyway, principal's time father, Pat Kelly, said no more proms at Cathedral High School, no more proms. Well, of course, I'm this young, I'm like, no, the kids gotta have prom, we gotta have prom. Father Kelly said, okay, then you figure out how you're gonna do it, so we don't have what we had, because we're not doing this again. It was, they were puking all over, they ruined, we had thousands of dollars in expenses. They embarrassed themselves, they threw up all over the band. I mean, it was a nightmare. So, it was a huge embarrassment for the school, not to mention it cost us a ton of money, and Cathedral had no money back in those days. So, anyhow, so we figured, okay, here's what we're gonna do. So we had a prom, and they had to be, they could drive there, they were breathalyzed when they got there, and it was only the dinner and the dance, and that was it. And then they left. But the kids were bemoaning the fact that your seniors, class of '86, were bemoaning the fact that all the other classes that had post-prom parties and everything, that they weren't gonna have one. And I said, I had this group of kids, I could be like your class, you know, a group that I really like, and I said, we can have a post-prom party at my house. And by golly, they did. We had limos lined up in my street, and they, at the time, I had a 1-year-old baby. I only had one kid at the time, she was only 1, and they came over after the prom. She was sleeping soundly in her crib, and we watched movies and had popcorn and made breakfast. They all brought stuff like bacon and eggs and all that. It was an amazing time. And then my neighbors were like all like, what's going on? Because I had these limos on the street. And it was a fun time. Then the year after that, we started doing. Mr. Ford kind of said, no, I'm not doing that anymore. So the year after that, we started having the post-prom down at the natatorium. Did you guys know we used to do that? We rented the natatorium, and we had like a Monte Carlo going in one of the gyms. You could play basketball, you could go swimming. We had mass, we had pizza. It was, yeah, well, I'll tell you what happened. Some kid drowned at the natatorium. Not in the cathedral, but they had a drowning at the natatorium, and all of a sudden, the rates to rent the place just went through the roof, so we couldn't afford it anymore. And we tried having a post-prom here, but it didn't work very well. So anyhow, I don't know why I told you that story, but this is our own prom right here. We're gonna solve this equation. And the directions say we're solving between 0 and 360. We're solving between 0 and 360. Okay? So here we go. Anybody have a thought on how to solve this very scary looking equation? Nobody has any ideas? You look at this, you don't notice anything about it? Van?
Factor out cosine.
Van is full of great ideas. He says, look, we have a GCF, you guys. We have the greatest common factor. So we're gonna pull out a cosine. What will I have left if I take out a cosine? 2 sine x minus 1. It's like regular factoring. If you take out the whole thing, you have to leave a 1 as a placeholder. But watching the clock, Brayden.
You can't even see the clock.
No, he's looking at the clock. So here we go. What do we do after we factor it? This is absolutely what you want to do. You want to factor it. Think of a regular factoring equation. If you factored something and got this, what would you do? You'd set them equal to 0. So cosine equals 0, or 2 sine minus 1 equals 0. So just like regular algebra, after you factor, set your factors equal to 0. Now, where does the cosine equal 0? Where does the cosine equal 0? I want you to think about your unit circle, your circle with a radius of 1. Think about all of these points. Where around that circle is the cosine 0? At the top and at the bottom. How does she know that other than she's smart? She knows that because cosine is x. And x is 0 right there and right there. So what are the angles? The answer to the question is the angles. So what is that angle? 90. That one. So the two answers so far are 90 and 270. Now, solve this one. What does this one say? Add 1, divide by 2. Doesn't it say sine equals 1/2?
Yeah.
Now that is not one of these, right? Zeros and 1s are here. 1/2 is out in a quadrant someplace. Where is the sign 1/2? Quadrant 1 for sure, because everything's positive there. Where else? What? 2. Yep. Sine is positive in 1 and 2. So 1/2 opposite over hypotenuse. So this would be root 3. How big is that angle right there? That's a 30. So this is a 30. So what are the answers to the question? Well, there's one of your answers, so that's 30 degrees. Be careful on the other one. The other one is the 30-degree angle that's in quadrant 2. How big is that orange angle? 150. 180 minus 30. 180 minus 30. So what are the answers to the question?
30, 90, 150.
That's right, 30, 150, 90, 270. All those are answers to the question.
So why was the 0 and 60 there?
This tells me I want to know all my answers between 0 and 360.
Oh,
So those are the boundaries. That's all the way around the circle.
okay.
So that's why I looked all the way around the circle and all the way around here to get all of the answers. All right, one more, and then we'll call it a day. This one looks very, very similar. Doesn't it?
Yeah.
What are you gonna do?
Take out a
Take out a tangent. So if we take out a tangent, we have root 2 cosine minus 1.
Yeah.
What do you do next? Set them each equal to 0. Oh shoot, I erased my circle. Tangent is 0. And am I skipping too many steps if I say cosine is 1 over root 2? Does that make sense to everybody? Set that equal to 0, add 1, divide by root 2. So anytime you have a 0, you're going to have to look at your circle again. Be careful. Tangent is y over x, right? Where does that equal 0? Y over x? Would that work? Not there. Y over x, would that work? Not there. So what are the answers to this piece? What angle is this?
180, 360.
We're really not supposed to include 360, so let's say 0. 0 and 360 are the same angle. 0 and 180. Now, these are in a quadrant. The cosine is positive. Where does that happen? Certainly quadrant 1. Where else is the cosine positive? 4. Whoa, wait a minute. 4, because cosine is x. So 1 root 2, wouldn't this be a 45-degree angle?
Yeah.
So my answers are 45 and 315. 360 minus 45. 45 and 315. All right, guys, good work.